Yellowstone, Wyoming. In spring 2003, strange things began happening in America's most famous national park. The tallest geyser in the world, which can go 50 years without erupting, burst into life, spraying columns of superheated water hundreds of feet into the air.
There were new cracks in the ground. The ground heated up to the point where the National Park Service had to close some trails.
Not long after, a group of bison collapsed and died, victims of poisonous fumes from below the ground. Satellite pictures revealed that something ominous was happening beneath the earth. On the internet, unfounded rumors spread that a supervolcano, an eruption so large that it only occurs on average every 700,000 years, was about to blow.
These things happen. You can look at the earth and see the scars. They happen and they're going to happen again.
Now, Naked Science asks, if Yellowstone experiences another super eruption, could the United States survive? The last supervolcanic eruption occurred 74,000 years ago, an explosion so large that it could wipe out a civilization. But what makes a supervolcano?
Supervolcano generates the biggest explosive eruptions that we've ever seen.
A single supervolcano explosion is 1,000,000 times bigger than Hiroshima. No ordinary volcano comes close. Regular volcanoes eject millions of cubic feet of ash and debris. Supervolcanoes eject billions. Regular volcanoes can throw ash over an entire state. The ash from a supervolcano could blanket half the United States. Supervolcanoes are real events. Over 20 have been recorded in the history of the Earth, and over half of these happened in North America.
Imagine a situation with worldwide famine.
People will be literally burnt to a cinder.
The results will be catastrophic.
We could be seeing 1 billion people dead. We could be seeing the start of a breakdown in the social fabric of the planet.
But where will the next supervolcano erupt? Many scientists now believe that an active supervolcano exists under Yellowstone National Park, prompting this not-so-trivial question. If Yellowstone erupted today, could we survive?
There's no technology that I can conceive of that could stop a super eruption.
It would be very difficult for the United States to survive as it is now.
Yellowstone National Park. 3,400 square miles of protected wilderness situated mostly in northwest Wyoming. The hot springs and geysers have attracted tourists for over 100 years. Unknown to them, deep beneath the beautiful landscape, lies a hidden terror. To find out what makes Yellowstone so potentially dangerous, Naked Science brought in geologist Bob Christensen. He has spent decades climbing over Yellowstone's rocks, uncovering its secret past.
Yellowstone is a unique place in the world. It's best known for its hydrothermal features, which is the name we give to hot springs and geysers and steam vents or fumaroles. All of these features are indicative of the great amount of heat that is pouring out from the interior of the Earth to its surface.
30 times more heat pours out of the ground in Yellowstone than anywhere else in the Rockies. Scientists had always assumed that the heat came from an extinct volcano that died long before the last ice age. Then, on August 17, 1959, a major earthquake changed that view forever. The quake triggered a giant landslide at Hebgen Lake to the west of the park. 80 million tons of rock broke off a mountain and crashed down onto a campsite. The quake killed 28 campers. 19 of their bodies were never found. It was the deadliest earthquake to hit the mainland United States since 1933. Since then, Yellowstone has become a laboratory. Geologists covered the park in seismometers. When they examined their data, they found Yellowstone averaged over 25 earthquakes a week. It was the most seismically active area of the United States outside California, but no one knew exactly why. The U.S. Geological Survey commissioned a huge study of the area. The man they chose for the job was Bob Christensen. His investigations first alerted people to the threat lying underground. Christensen and his team quickly realized that Yellowstone was the site of a large volcanic eruption. A thick layer of ash and debris covered the bedrock. It must have come from a volcano.
So all of these materials erupted together in a volume accumulating to about 250 cubic miles. Now that's an inconceivably large volume.
That's enough material to bury the whole of Texas under 5 feet of ash. But Bob wanted to know, where was the smoking gun, the enormous volcano the ash had come from? Ordinary volcanoes are easily recognized from their distinctive cone shape. But Bob couldn't find any sign of a cone in Yellowstone. Over the next 5 years, he carefully mapped the terrain. What he found was not a cone, but something more astonishing. A crater so large that it was impossible to see it all, even from the air. Here was the site of a supervolcano. But how had it formed? Several miles beneath every volcano is a magma chamber, an area of molten rock. In the case of a supervolcano, the magma chamber is huge, tens of miles in diameter. When the pressure in the chamber gets too great, the magma erupts, and the ground above collapses into the partially empty chamber, creating a giant depression in the earth, a caldera.
Dimensions of the magma chamber were at least 50 miles long by about 25 miles across.
The caldera was enormous. The whole center of Yellowstone Park had once blown out and up. This was the site of an incredible eruption, one so large that it must have affected the whole planet. To understand just how big this eruption was, we compared it to the United States' biggest volcanic eruption in living memory. Mount St. Helens erupted in May 1980, blasting 7 billion tons of rock from the side of the mountain, enough debris to bury Manhattan to a depth of 55 feet. The eruption was equal to 500 Hiroshima nuclear bombs. It flattened an area of forest 3 times the size of Washington, D.C., and sent ash 15 miles into the sky. By any measurement, it was big. But the eruption that created the Yellowstone caldera was much, much bigger, an astonishing 1,000 times greater than the Mount St. Helens blast. But there was another surprise. From analyzing the layers of ash, Bob found 2 other giant calderas. One was even bigger, 60 miles long by 30 miles wide. The eruption that caused it was 2,500 times the size of Mount St. Helens.
This is the spot where we first recognized the distinction between these two volcanic units and realized that Yellowstone has had a much longer, more complicated history of evolution and was appreciated at first.
Bob had discovered 3 enormous eruptions right in the heart of the United States. Yellowstone gave birth to several supervolcanoes, which raises the unnerving thought, could Yellowstone erupt again? Geologist Bob Smith has been trying to answer that question. Bob Smith grew up with Yellowstone. He had his first job in the park 50 years ago. He's gathered evidence that suggests that our worst nightmares about Yellowstone could be true. In the 1970s, he was revisiting Yellowstone Lake when he noticed that the landscape had changed since he was last there.
Trees just at the edge of the lake seem to have water in the root systems and been inundated by a few inches of water.
Strangely, this only occurred at the south end of the lake. Bob came up with an extraordinary theory. He suggested that the whole north end of the lake had risen, pushing the water to the south. To check his theory, he organized a new survey of the land which hadn't been surveyed since the 1920s.
We went to the old benchmarks that were set up along the highways by the original road surveyors. The surveyor said to me, well, these people really have made a big error, these people in 1923, because I'm off from them some like 18 inches to 2 feet.
A thorough check revealed that the original survey was correct. This meant that between 1923 and 1977, the center of the caldera had risen over 2 feet. But that wasn't all. New surveys in the last 10 years revealed a further surprise.
Well, lo and behold, the ground was going down between basically 1995 and 2000. So we were pretty excited because it gave us this idea that it's dynamic and it's truly alive. This is really kind of a living, breathing caldera.
It looked like the volcano was still active. But could this amazing discovery be true? Naked Science tracked down a scientist who has crucial evidence that supports Bob's theory. That evidence comes from people who died centuries ago. For over 11,000 years, Native Americans lived around the lake, hunting the bison that came here to drink. The primitive weapons they left behind reveal the position of their settlements. Archaeologists have collected these arrowheads and mapped their locations. The arrowheads show that the native villages moved back and forth 6 times over the last 15,000 years as the edge of the lake rose and fell. The rise and fall of the caldera shows that the volcano is active. That makes it a massive ticking time bomb. If it erupts, it could be the biggest blast in the history of mankind. For the first time, Naked Science can show you what will happen if Yellowstone erupts. It's a dramatic spectacle, and the result would be no fun at all. Yellowstone National Park is sitting on a time bomb, a supervolcano so large that it could throw debris 15 miles high, trigger monster avalanches, and generally wreak havoc. To see if the United States could survive a Yellowstone super eruption, Naked Science needed to know just how big that eruption would be. We traveled to London to meet Bill McGuire, one of the world's leading experts on volcanoes.
A supervolcano generates the biggest explosive eruptions that we've ever seen.
Geologists measure eruptions using the Volcanic Explosivity Index.
It's a little bit like a volcanic Richter scale, and it runs from 0 up to 8.
At level 1 are tiny eruptions throwing 350,000 cubic feet of ash into the air. Level 2 eruptions are slightly bigger, like this blast from Mount Etna in Sicily. This volcano in New Zealand, ejecting enough ash to fill 58 football stadiums, is a level 3. The 1883 eruption of Krakatoa in Indonesia was a level 6. A supervolcano? Make that level 8.
Each point on that scale represents an eruption 10 times bigger than the one below.
Mount St. Helens was a 5. A super eruption is at least 1,000 times bigger. But what factors make supervolcanoes like Yellowstone so explosive? The answer lies in the type of magma or molten rock that triggers the eruption. Quiet volcanoes, like Kilauea in Hawaii, have a very runny magma called basalt. When the magma reaches the surface, any gases trapped within it escape gently. There's no violent eruption. But the magma beneath Yellowstone is completely different. It contains larger amounts of a substance called silica, which can bind vast quantities of explosive gas into the magma.
If you combine that binding phenomenon with lots of gas, then you have a recipe for a really big explosion.
A supervolcano isn't just the world's biggest bomb. It's a bomb that throws smaller bombs. To see what sort of bang it would make, you need to compare it to the largest man-made explosions ever. This is the most powerful bomb ever detonated by the United States. It's the Castle Bravo hydrogen bomb, set off on Bikini Atoll in 1954. But at 15 megatons, it's still 160 times smaller than a supervolcano eruption. This is the world's biggest bomb. In 1961, the Soviet Air Force dropped a 50 megaton bomb over Novaya Zemlya in the Arctic Ocean. The mushroom cloud rose above the stratosphere, and the shock wave traveled 3 times around the Earth. Imagine an eruption 50 times bigger than this, and you have a supervolcano. Any way you look at it, that kind of eruption would be a very nasty surprise. So how will the emergency services know that a super eruption is on the way? All volcanoes warn us that they are about to erupt. The first sign of a Yellowstone eruption would probably be the ground rising. Just before Mount St. Helens erupted, the mountain bulged, growing 5 feet per day. A similar kind of uplift would be likely at Yellowstone. As magma deep below the surface of the Earth rises, it splits the rocks above. In Yellowstone, it would probably lift the whole caldera, an area the size of Houston and Dallas, 10 feet or more into the air. Weeks or even months before a Yellowstone super eruption, these warning signs would trigger the mother of all evacuations. The area 60 miles around the volcano would become a hazard zone. Officials would place on alert the surrounding region, up to 200 miles, readying people for a violent eruption.
Roadblock set up, East River Road, Concrete.
As people evacuated the area, geologists would look out for new warning signs that would tell them an eruption is imminent.
You start to see swarms of earthquakes as fresh magma moved into the system and broke the rock above it, and it started to rise upwards.
These earthquakes produce distinctive waveforms on the seismographs. The crack of rocks fracturing creates a signal that starts with a sharp rise and fades quickly. Long before an eruption, swarms of earthquakes would sweep the hazard zone and surrounding area. Just before a volcanic eruption, the signal produced by regular earthquakes would give way to a new signal, a long, continuous vibration.
Now, when magma's opened a space for itself, it will start to move through that, and as it moves through that very rapidly, it will vibrate the walls of the crack or the conduit, and that will give you a sort of rumbling signal.
It sounds like the vibration of a large organ pipe. Scientists call it harmonic tremor. It's the last warning. This is what magma racing towards the surface might sound like. For anyone brave or foolish enough to remain in the hazard zone, the chances of escape would be slim. The Big Bang would be moments away. The blast of a super eruption would be awesome enough, but it's nothing compared to what would follow. Spreading out from Yellowstone would come one of nature's most deadly forces, violent churning clouds of rock, ash, and gas called pyroclastic flows.
Pyroclastic flows are the nastiest of all volcanic phenomena. They are blasts of fragmented magma, hot ash, incandescent gases that travel at hurricane velocities, and they blast out across the ground surface in all directions from the eruption.
It's like an avalanche on steroids. Hidden beneath the turbulent cloud of scalding hot ash is a mass of tumbling rocks. At temperatures as high as 1,500 degrees Fahrenheit, it sweeps down the mountain at high speeds, destroying everything it touches. There's nowhere to run and absolutely nowhere to hide.
Death comes pretty quickly, not from the actual burning of the skin outside, but from inhaling these very, very hot gases. And they really wreck the lungs and the throat almost instantaneously. After that, the water in the human tissue is boiled off, and there are cases in some past eruptions where people's skulls are seen popped apart as the brain essentially has exploded.
For tangible recent evidence of the nasty nature of pyroclastic flows, Naked Science paid a visit to the Caribbean island of Montserrat. Hell came to this paradise in 1997 in the form of giant pyroclastic flows. David Lee is a local filmmaker. In 1995, he had a hair-raising run-in with an exploding volcano.
There's an eruption right now. That's hot stuff going up. There's rocks coming up, and I'm getting out of here.
He had climbed to the summit of the volcano to film it when it erupted.
Now do I look scared? I'm not out of here yet. I'm only down about 600 feet. If the whole thing went, wouldn't have a chance up here.
You could have seen pyroclastic flows rushing down those slopes at fantastic speeds, maybe 60 to 100 miles an hour, maybe even more. And they rush out over the ocean and they just float out over the sea. It's an amazing thing to see.
The power and fury of these pyroclastic flows are awesome. But they're nothing compared to what would spew forth from a supervolcano. To see what happens when a pyroclastic flow hits a major town, Naked Science visited Plymouth on Montserrat.
We're just coming into the capital city of Montserrat, which was Plymouth, and it has been hit by pyroclastic flows and devastated in 1997.
David Lee witnessed the flows that hit the town. The experience is seared in his memory.
At the daytime, they look like a gray mass. You wouldn't even think they were dangerous, although they're moving quickly. At night, they are totally on fire, totally incandescent, just glowing, and you could see them sweeping down over the city, and everything they touch, because they're probably 500 degrees or more, just bursts into flame. Most of the population was up on the hillsides as close as we could get, and you could see the whole city burning.
Once, over 4,000 people lived here. Today, it's a ghost town. The city center is buried in ash, a modern-day Pompeii. Montserrat's disaster was appalling, but its volcano was relatively small, and life on the island has begun to recover. If this had been a supervolcano, we'd be looking at no life whatsoever. Within an hour of a Yellowstone supereruption, pyroclastic flows could race across the countryside and engulf the valley of Jackson Hole and the town of Livingston, some 50 miles away. Within a 60-mile radius, 90% of any remaining people would be killed. A few might be blown to pieces in the initial blast. Most would suffocate in the heat of pyroclastic flows. But this would just be the beginning. Blowing across the states would be the mother of all ash clouds, an aerial mountain of deadly particles and debris. Yellowstone National Park is the site of a recurring supervolcano, an eruption so large that if it happens again, it would destroy nearly everything within 60 miles. But what would happen next as a mountain of ash begins to spread and then fall? The Yellowstone supereruption could throw ash 15 miles into the atmosphere. The fallout could cover half the United States. 3 days after the eruption, the skies would be dark and deadly. From scientists' predictions, Naked Science has pieced together a picture of the country after 3 days of ashfall. At 6 times heavier than wet snow, wet ash would cause many roofs to collapse, clog up filters of cars, and ground aircraft across much of the western U.S. Any planes in flight would be in danger of crashing, their engines clogged by the fine particles. When Mount St. Helens erupted, swirling particles of ash in the atmosphere generated lightning, which in turn ignited scores of forest fires. A supervolcano could ignite hundreds. The worst affected region would be the downwind area up to 500 miles from Yellowstone, as far away as Salt Lake City and Denver. Carried by the normal prevailing winds, the ash would reach Denver in about 24 hours. By the time it had finished falling, it could be deeper than 3 feet. Within this zone, no movement would be possible for 2 days. Roads would be invisible, and people outdoors would not be able to see where they were going. Transportation would come to a stop. Winds whipping up the ash would create dust clouds, and people stranded in the open would likely suffocate within hours. Moist ash collecting on power lines would short insulators, cutting off power. If it happened in winter, then the cold weather would take more lives. Falling rain would wash ash into rivers, creating giant mud flows called lahars, smashing everything in their path. Pumping stations at reservoirs would be clogged with ash, leaving many people without fresh water. Nuclear power stations dependent on cooling water from rivers would be forced to close. As with the aftermath of any catastrophe, lawlessness could take over. Livestock could die from lack of grass and water. Hospitals could stop running. The old, the sick, and the very young would be even more vulnerable. In this central zone, up to 10% of the population, or 500,000 people, could die. 7 days after the eruption, Yellowstone could still be pumping ash into the air. 1,000 miles away, in places like Santa Fe and Kansas City, the ash would continue to fall and to kill.
Keep one low on your head.
The ash itself is deadly. Anyone living under the path of the ash cloud would need to protect themselves. That's because volcanic ash isn't really ash at all. It's rock that has been blown apart into tiny pieces. To see what makes it so dangerous, naked science put it under an electron microscope. Up close, the particles show up as minute shards of glass with jagged edges. If these get into the lungs, they can be deadly. But not the way you might expect. To find out what can happen to people who inhale this ash, Naked Science traveled to Nebraska to meet Mike Voorhees, a respected American paleontologist. In the 1970s, Professor Voorhees made a startling discovery.
I was prospecting for fossils here and came across this volcanic ash bed. And right at the bottom of the ash bed was a skull of a baby rhinoceros sticking out.
It was the start of an incredible find. Underneath 10 feet of ash was an ancient waterhole, full of skeletons of horses, camels, and rhinos. The mass grave contained over 200 animals. All died within days of each other. Scientists suspected the killer was ash, but they had no proof. When the ash was tested, they were shocked to find that it had come from an extinct volcano almost 1,000 miles away in Idaho. Mike's discovery led him to conclude that volcanic ash can kill even 1,000 miles from its source. But how?
I think I can demonstrate how it did it. The ash is so fine that it drifts easily on the wind. So it probably took maybe 6 or 7 hours for the ash to get to Nebraska from the volcano.
Fine ash hangs in the air, the same air we breathe.
This ash is so far from the volcano that only the very, very finest material settled out here. So it's so fine that it makes a dust that easily gets into the lungs.
In his laboratory, Mike and his team started examining the bones. There was something unusual about them.
Right up here in the front part of the jaw is healthy bone. This is the way a fossilized camel jaw should look. But this one has something extra. It actually has symptoms of the disease that killed the animal.
Unlike normal fossils, every single bone they found was covered in a strange white substance. The white spongy substance is new bone growth. It's a classic sign that an animal has died of the rare lung ailment known as Marie's disease. As the lungs fail, the skeletal system goes out of control, rapidly depositing new bone on top of old. It reveals that the animals died a slow and painful death. As their lungs, choked by ash, started to fail, it caused their bones to grow thicker. Racked with pain, they were drawn to the waterhole where they died, all within a month of the eruption. If If the Yellowstone supervolcano erupts, no one within 1,000 miles would be safe. Prolonged exposure to the fine ash would guarantee a lingering death from Marie's disease. The death toll from the immediate blast of a Yellowstone eruption would be bad enough. But for those who survive the explosion and even the ashfall, it could get worse. DNA evidence suggests that the last supervolcano eruption created a mini ice age that nearly led to the extinction of the human race. An eruption of the Yellowstone supervolcano would cause widespread devastation across the United States. In the first day, those spared by the initial blast would face pyroclastic flows that would sweep out from Yellowstone, destroying nearly everything within 60 miles. 3 days after the eruption, normal life within 500 miles of the volcano would be impossible. Within a week, the center of the U.S. would be buried under a thick carpet of ash, killing thousands with a painful lung disease. But scientists now suggest that the greatest impact would come months after the eruption. They believe that the deadliest part of a supervolcano eruption is not the ash that falls to the ground, but the gases that stay in the air. Professor Mike Rampino of New York University investigates how volcanic eruptions in the past changed the climate of the planet. To find out what will happen if Yellowstone erupts, Naked Science brought Professor Rampino to New England. An old tombstone in a New Hampshire graveyard contains a warning of what a supervolcano would bring. It records the events of 1816, a date that became known as the year without a summer.
And this is a memorial to a farmer named Reuben Whitten, who managed to save the town of Ashland, New Hampshire in 1816 by growing enough wheat on his land to feed the community. There was snow in June and frosts in July and again in August that killed most of the wheat in the lowlands, but Reuben Whitten managed to grow enough wheat in the highlands here to feed the town.
They were lucky. In 1816, the growing season in New Hampshire dropped from 120 days to just 60, killing the crops in the ground before they could ripen. And it wasn't just America that was affected. Bad weather caused harvests to fail in Europe. 1816 to 1817 witnessed the worst famine in over a century. The cold weather was believed to be caused by a volcano. To find out more, Mike Rampino went to Harvard University to search the historical records. They show that in 1815, the year before the cold summer, the volcano of Tambora to the east of Java blew its top. Although not a super eruption, this volcano, even at 10,000 miles away, had a far-reaching effect. It's our best clue to what will happen when a supervolcano erupts.
Explosive volcanoes put material up into the stratosphere, and the most important thing is they release sulfur dioxide gas, which is converted into sulfuric acid aerosols, little droplets, in the Earth's atmosphere in the stratosphere.
Scientists agree that what made Tambora such a killer was the 200 million tons of sulfur dioxide it pumped into the air.
These tiny droplets are spread worldwide by the stratospheric winds, and they produce a veil that covers the Earth and cuts out some of the sunlight that's coming in, so that the sun actually appears dimmer. And so less sunlight is warming the Earth, and it's natural then the Earth cools down.
This dimmer effect caused the famine of 1816. By some estimates, Tambora killed 71,000 people, twice as many as Krakatoa, mainly through starvation. It's the deadliest volcanic eruption in recorded history. A supervolcano's effect might be even greater.
The effect it would have on the atmosphere is much more severe than any of the historic volcanic eruptions like Tambora. And we estimate that the drop in temperature globally after a Yellowstone-sized supereruption would be about 10 degrees Fahrenheit. Now, that is a very severe cooling. Frost and snowfall, and even in equatorial regions. Tropical vegetation has no cold hardiness. So a frost in the tropics would kill off all the above ground vegetation. And in that kind of situation, the climatic effects, the loss of the growing season for 1 or 2 years, it's been estimated that you could lose billions of people from the Earth's population.
Evidence suggests this type of climate change has happened before. Some scientists believe that the last time a supervolcano erupted, it very nearly wiped out the human race. 74,000 years ago, a supervolcano erupted on the island of Toba in Indonesia.
It's a very, very large volume eruption, the same kind of thing we might see from Yellowstone. And it's interesting to note that at that time, there's genetic evidence that the human population went through a bottleneck.
Before the volcano erupted, scientists believed that humans were abundant throughout Africa. Around the time of the eruption, their numbers plummeted.
The population of human beings in that bottleneck was about a few thousand. At most 10,000, some people think as little as 3,000. So imagine the entire human population of the planet at that time reduced to a few thousand individuals. It's very close to an extinction of Homo sapiens.
According to these scientists, a supervolcano has nearly ended human life once already. Could it happen again? And just as importantly for us, when? An active supervolcano lies in waiting under Yellowstone National Park. If it were to explode, it could plunge the world into a volcanic winter. As the global temperature dropped, millions could die. It would be by far the biggest disaster ever to hit the modern world. It sounds terrifying. But if it happens 500,000 years from now, we're not quite so worried. If it's 5 years, start packing. So when will Yellowstone next erupt? The scientist in charge of Yellowstone Volcano Observatory is Jake Lowenstern. If Yellowstone is about to erupt, it's his job to see it coming. Using the very latest technology, he can tell what is happening below ground at any time.
There's over 20 seismometers that are located within the park. The seismic data is recorded continuously, sent to the University of Utah.
The key to knowing when Yellowstone is going to blow is understanding the composition of the magma underground. The magma deep below Yellowstone is made of 3 things: gas bubbles, crystals of cooled magma, and a certain percentage of molten rock or melt. Before a volcano can explode, the magma chamber has to contain enough melt to trigger the eruption.
Generally, it appears that about 50% melt is needed in a magma for it to erupt.
So what percentage of rock below Yellowstone is melt? To find the answer, scientists have recently analyzed the seismic waves created by earthquakes. Like a giant ultrasound scan, these allowed them to see into the earth and estimate the percentage of melt below ground.
We do have some data that indicates that the magma chamber on a caldera-wide basis is only about 10% melt, and therefore it doesn't seem likely at this time that Yellowstone caldera could have one of these really large caldera-forming eruptions. There's just not enough highly molten material down there.
But in 2003, geologists monitoring the volcano saw unusual signs that Yellowstone was becoming more active. Dan Durishan is a geologist with the U.S. Geological Survey's Volcano Hazards Group. He was one of the first to see the signs of the increased activity.
The tallest geyser in the world erupted several times, Steamboat Geyser.
A very rare event.
There were new cracks in the ground. The ground heated up to the point where the National Park Service had to close some trails. We discovered that a different part of the area was going up. And frankly, the only thing we can think of that could be down there that would be causing the uplift is magma. It could mean that the system is getting closer to its next eruption and we're starting to see intrusion of magma. We don't know.
So what could these signs mean? In the past, the Yellowstone supervolcano has erupted 3 times.
These things happen. You can look at the Earth and see the scars. They happen and they're going to happen again.
Yellowstone appears to be in a cycle.
The last 3 super eruptions at Yellowstone occurred 2.0 million years ago, 1.3 million years ago, and 0.6 million years ago. Well, that sounds like we're getting ready for the next eruption.
But these dates are not an exact cycle. The eruptions varied by plus or minus 100,000 years. This means that the next Yellowstone eruption might not happen for another 100,000 years.
So will the next one occur at 0 or 100,000 years from now? We don't know.
According to the scientists, it's unlikely that Yellowstone will blow in a super eruption at any time soon. But one thing is sure, super eruptions do happen. And being a little cautious, we wanted to know if Yellowstone were about to explode, is there any way we could stop it? Some have suggested that the way to prevent a supervolcano eruption would be to drill hundreds or thousands of holes down to the magma chamber to release the pressure of the gases.
It just wouldn't work. First of all, it's a technological challenge to drill to the depths of these magma chambers, on the order of 6 miles perhaps in some cases. But even if you drill that far, all you would be doing is a pinprick in a very large, very complicated system. It's not just a big balloon full of magma, and it wouldn't notice. There's no technology that I can conceive of that I've ever heard discussed that could stop a super eruption.
So we can't stop one with any known technology. If Yellowstone blows, is there any way the United States could survive?
It would be very difficult for the United States to survive as it is now in the immediate aftermath of an eruption, a super eruption at Yellowstone.
The United States would be crippled. Thousands could die in the blast. Millions more could perish from breathing in ash or from the famine that many predict. But recognizing the danger and detailed disaster planning could yet offer hope. Some scientists believe the preparation of hardened facilities would allow survivors to dig themselves out and respond effectively. The size of the underground threat means that Yellowstone will be on round-the-clock surveillance for centuries to come. Fortunately for us, supervolcanoes are extremely rare events. On average, one erupts somewhere on Earth every 700,000 years. The challenge facing scientists is finding where and when the next one will happen before it's too late.